Good afternoon, ladies and gentlemen. I'm Dr. Alistair Dewar, a Principal Radiological Protection Scientist at CFAS, and I'm the Scientific and Technical Lead for the Radioactivity in Food and Environment Report series. The purpose of this talk is to give a brief outline of radiological monitoring in the Northwest, giving a brief outline of the sites, habit surveys, and monitoring, and present trends in total dose and monitoring data. The RIFE report is produced on behalf of the UK Environment and Food Standards Agencies. There are 6 sites in the Northwest: Chapel Cross, which is a nuclear power station undergoing decommissioning; Sellafield, which is a former reprocessing plant, now itself decommissioning; Whitehaven, which is a former phosphate processing plant for detergents; the low-level waste repository near Drigg; the VA Systems facility at Barrow for submarines; and Heysham, 1 and 2, both operational power stations. Habit surveys are performed regularly to obtain the consumption of food and seafood, time spent on local beaches, shoreline areas, and determine occupancy close to nuclear sites. These are used to support the radiological dose assessments and also the monitoring programs. All of the sites listed on the previous slide have had surveys done within the last 10 years. Whitehaven is covered by the Sellafield and low-level waste repository surveys, and these are surveys are performed regularly. So in terms of radiological monitoring, on the right we have a map showing the sampling locations around the Sellafield site as part of the RIFE monitoring programs. These are then analysed using gamma spectrometry and radiochemical methods by various agencies involved. And the selection of samples is also based on habits information. On this slide, we present the trends in total dose around the sites in the Northwest. The doses from the low-level waste repository and Whitehaven are captured as part of the Sellafield plot, where the majority of dose arises from the naturally occurring radioactivity, in this case polonium-210. However, in all cases, the doses are well under the dose limit of 1 millisievert per year. Generally, as the trend plots we have in RIFE are based on 12 years. So these are from 2012 to 2023, which represents the latest publication date of RIFE. Where we have differences to this, we'll go through and explain those changes of the differences as we go through. So for this plot, we are looking at the trends of cesium-137 in sediments around the Chapel Cross and Heysham nuclear power stations. In both cases, the concentrations exhibit a Sellafield-derived component, but are low. The next trends plot we're looking at is for over a much longer time period, covering 1990 to 2023. Around Whitehaven and Sellafield, the Food Standards Agency look at the polonium-210 concentrations in fish and shellfish, these are the dominant contributors to dose in most recent years. For this plot, we have the discharges of polonium-210 from the Whitehaven plant, and in 1992 the plant changed operations and these discharges were substantially reduced prior to the plant's closure in the late 1990s. The horizontal lines represent the range of the background for polonium-210 in lobsters, the minimum, median, and maximum. And as can be seen, the concentrations for lobster are above background, and this is what is driving dose on the Cumbrian coastline. And now looking at concentrations around Sellafield in particular, This plot shows the low discharges and concentration of carbon-14, strontium-90, and cesium-137 in milk around the Sellafield site. And as in the last few years, those discharges have reduced further and the concentrations have remained low throughout. In this slide, we're looking at the discharges and concentrations of carbon-14 and fish in fish and shellfish. The discharges and concentrations are on a downward trend over the last 5-10 years since the cessation of reprocessing at the site, in particularly Thorpe in 2018. Now, looking at the discharges and concentrations of technetium-99, another radionuclide produced as part of the reprocessing process. And this is as over the last 12 years, the concentrations and discharges have been generally low into the environment. The next slide is looking at the discharges and concentrations, this time of cesium, in both fish and shellfish. Again, the discharges and concentrations are generally low with environmental variability between years. Now looking at for plutonium-239 and 240, we can't distinguish the measurements between these nuclei, so we group them together. And looking at them in fish and shellfish, again, the discharges are generally low with environmental variability between years, and the concentrations have been generally lower over the last few years. For this trends plot, we're looking at the concentration and discharges of americium-241 into the environment and the concentrations in fish and shellfish over the last 12 years. Again, the concentrations and discharges are generally low with environmental variability between years. Now this slide the next two few slides are looking at the concentrations in environmental media. In this slide, we're looking at the discharges and concentrations of cesium-137 into sediment over a much longer time, a 30-year time period. And again, the concentrations are generally low over this time span. The final trends plot we're looking at is for the discharges of technetium and the concentrations of that radionuclide in seaweed over a much longer period. As can be seen, the discharges have fallen from the mid-90s prior to a change in the reprocessing of process, and the technetium-99 was encapsulated by various methods. And correspondingly, as the discharges have reduced, the concentrations have also fallen as well. So all this, the trends plots, doses, and information feed into the Rife report, and alongside these and other trend plots with further discussion can be found in the report itself, which can be found at the link shown below on the slide. Finally, thank you for your attention. If you have any questions or would like any further information, then please contact me at the email address shown on the slide. Thank you again. Thank you very much.